Hello, everyone. Welcome back to Math with Allison. Today we're working in our sequences and series. So we're going to be talking about the P series. So let's go ahead and dive into it. Question of the day, what is a P series? So first, let's take a look at some examples. First, we have the summation k equals 1 to infinity of 1 over k squared. We have another one. We have the summation of 1 over to the square root of k. And then one more, we have 1 over k to the power of 4/5. All of these have something in common, and it's that they all are to a power, right? Where we have the square root of k, that's going to be 1 over k to the 1/2. So notice all of these are 1 over k to a power. That is exactly what a P series is. So here we have the P series, the summation k equals 1 to infinity of 1 over k to the power of p. This converges when p is larger than 1, and it diverges when p is less than or equal to 1. If p is equal to 1, then we have the harmonic series, which does diverge, right? But let's go ahead and figure out these cases. Why does it work this way? So here we have the proof, and what we're going to do is use the integral test. We're going to work with a function f of x equals 1 over x to the p, which is similar to our series, right? We're just writing it out as a function. Now remember, in order to use the integral test, we need to make sure that this meets 3 conditions. The first one is that it is continuous. Well, whatever the power of p is, 1 over x to whatever power is always going to be continuous, right? It does not contain any illegal values. The only illegal value would be 0 because you can't plug in 0, but we don't have to worry about that because it's not in the domain. So we have that it's continuous. We also need to have that it's positive. Well, we're only plugging in positive numbers, and no matter what power it is, a positive number to any power is always positive. So we have that it's continuous, we have that it's positive. We also need to have that it's decreasing. We know that this is going to be decreasing because as x gets larger and larger, 1 over that larger number becomes smaller and smaller, right? Like if we had 1 over x squared, we would have 1 over 1 squared, which is just 1. We'd have 1 over 2 squared, which is 1/4. 1 over 3 squared, which is 1/9, right? And we would just be getting smaller and smaller. No matter what the exponent is, that's going to be the same pattern, right? So since all of these 3 conditions are met, we can go ahead and use the integral test. So what we're going to do is set up our integral. We're going to take the limit as b approaches infinity. Our lower limit is 1, our upper limit is b, and then we have 1 over x to the p dx. So let's go ahead and rewrite this so we can see power rule really well. I'm going to rewrite it as x to the negative p because we can go ahead and apply power rule. I'm going to add 1 to my exponent, so negative p plus 1, and I'm going to divide by that new exponent. But I want to go ahead and rewrite this as a fraction. So what I'm going to do is I'm going to bring that x to the p, negative p plus 1 to the denominator. But remember, that's going to flip the signs of everything. So what it becomes is 1 over negative p plus 1 times x to the positive p minus 1. So now what we can do is plug in upper minus lower. And remember, we are replacing x. So here we get our upper bound of b. Here we get our lower bound of 1. Which we can actually go ahead and simplify that because 1 to the p minus 1, that's just always going to be equal to 1. So this right here is the limit that we're working with. Now, p minus 1 here in the exponent is going to tell us a lot of information. So let's go ahead and go through it. If p is greater than 1, p minus 1 is going to be positive. So for example, if p is equal to 2, we would have b to the 2 minus 1, which is equal to b to the first. That means that the b, the infinity, stays in the denominator, and 1 over infinity goes to 0. So this tells us that it's going to converge. Now, what happens when p is less than or equal to 1? If p is less than or equal to 1, or if it's equal to 1, p minus 1 is 0. That's not going to help us. That's going to be the harmonic series, so we can ignore that for now. But if p is strictly less than 1, then p minus 1 is going to be negative. So what happens here is that if p is equal to 1/2, for example, we have b, 1 over b, we'll say for now, of 1/2 minus 1. That is equal to 1 over b to the negative 1/2, which actually would be the square root of b divided by 1. So what happens is that infinity goes to the numerator. And when it's in the numerator, it's going to diverge. So let's go ahead and go through some examples of this. First, we have the summation k equals 1 to infinity of k to the negative 3. So here, what we're going to do is we're going to rewrite it so we can really see the p series going on. And I'm going to use properties of exponents, and we get 1 over k cubed. P in this case is equal to 3, which is going to be strictly greater than 1, which tells us this series is going to converge. But let's go ahead and work it out with the integral test. We have that our function that we'll be working with is going to be 1 over x cubed You can make sure it meets all three conditions. We know it's going to be continuous, we know it's going to be positive, and we know it's going to be decreasing. So here, let's go ahead and set it up. The limit as b approaches infinity of 1 to b of 1 over x cubed dx. And I'm just doing it so we can understand the p series a bit better. And I'm going to rewrite that as x to the negative 3 so we can really see exponent rule going on. So this becomes x to the negative 2 divided by negative 2 evaluated between 1 and b. But again, I'm going to rewrite that. So that's going to be negative 1 divided by 2x squared. So here we can go ahead and plug in upper minus lower. And notice what's going to happen. Since our p-value was greater than 1, what happens is that this right here, as b grows infinite, is going to approach 0. So this is equal to 0 plus 1/2, which is equal to 1/2. So also by the integral test, we can understand that when p is greater than 1, this is going to converge, right? It's not going to converge to 1/2. It's going to converge to some number. It's not going to be 1/2, but it just means it's going to converge, right? Let's go ahead and try this again. We have the summation k equals 1 to infinity, and I'm going to go ahead and rewrite that as k to the 3/4. In this case, p is equal to 3/4, which is going to be less than or equal to 1, which tells us that the series is going to diverge. Let's go ahead and work it out with the integral test so we can really see what's happening. The function that we're working with is going to be 1 over x to the power of 3/4. It meets all three conditions. Make sure to write that down if you're taking an exam, right? It is continuous, it is positive, and it's decreasing over this interval. So let's go ahead and write out our integral. The limit as b approaches infinity, we have 1 to b of 1 over x to the 3/4 dx. Again, the first thing I want to do is rewrite this so I can really see power rule. So it's going to be x to the negative 3/4. So here we have the limit as b approaches infinity of, we add 1 to the exponent, so that becomes 1/4. And when we divide by 1/4, we can just multiply by 4. So we get 4 times x to the 1/4. And then this is being evaluated between 1 and b. So here I'll go ahead and plug in upper minus lower. So notice here what happens when p is less than or equal to 1. This becomes infinite. 4 times the fourth root of infinity is going to go to infinity. So this is going to approach infinity, right, which tells us that it's going to diverge. So that's how the p series works out. Let's go ahead and try a bit more complicated one. We have the summation k equals 4 to infinity of 1 over k minus 1 to the power of 2. We can manipulate this to look like a p series. So what I want to happen is I want this to be k squared, right? I don't want to have that minus 1. So what happens is I need to add 1 to k in order for that minus 1 to cancel out. So how do I add 1 to k? Well, I subtract 1 from the index. If I start at 3 instead and go to infinity, what happens is when you subtract from the index, you add that amount to k in your little formula. So k plus 1 minus 1 to the power of 2, well, those minus 1s and plus 1s cancels out, so we get k equals 3 to infinity of k squared. Question is it okay for us not to start at 1? And yes, it is, because what we're doing is like we're losing those first two terms, which just makes the entire summation a little smaller because we don't have those values. But no, if it's going to converge, it's going to converge. If it's going to diverge, it's going to diverge. Those first two values are not going to affect it that much. So by the p series, this series is going to converge. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.